It's Mrs. Flynn,
And Mr. Ross.
and we're here today to talk about volumes of solids.
Hooray! Woohoo!
Okay, so if we have a cube, to find the volume, we have a formula.
Right.
Ooh, better go
Right.
here.
And the formula, well, for this one is just length times width times height, which is, they're all the same, so S cubed.
Is that what you do? I usually always write area base times height.
Ah, right. Let's talk about that. Base times height.
Here's just a general formula for any three-dimensional shape, right?
Mm-hmm.
Area base times height.
Nice.
And then we can, from there we can say area of the base. We all know base is
S squared.
S squared and times the height, which is S, and we get S to the third.
Sweet. And that one, if we do the same kind of thing, area of that base is length times width. That's the area of the base. And we take that square, we multiply that square by the height, which is h, and we get our volume.
All right, then we're over here to the cylinder, and again, area of the base. We think how we take the area of that.
Right. And that's just a circle.
And that's pi r squared.
So the base is the circle times the height.
Height.
All right, and this one here, volume of the area of the base is known to be A. So we are assuming that the area of that base is big A.
So this whole thing right here is large A.
Okay.
Times
Height, H.
H.
They all kind of look the same. Area of the base times the height. Area of the base times the height. Okay, let's
All right.
go to our next figures. All right, and so now, triangular base prism. Well, or pyramid, sorry. Triangular base pyramid. Well, with pyramids, any kind of pyramid, it's always, as opposed to the area of the base times the height, it's always 1/3 the area of the base times the height.
All right, so you want to go any further with that?
No, I think we'll just leave it at that
Okay.
because we might be given different information for how to find that area, that base triangle.
All right, so what about a rectangular base pyramid?
Okay, well that's still going to be 1/3 area of the base, but the area of this base specifically is a length times width.
And multiply it by,
The height. Now is the height the same as the slant height?
oh no, those are absolutely different. How do you tell?
That one looks like it's perpendicular to the base.
Yeah, we always want to look for perpendicular lines. That tells you which one is base and which one is height.
Okay. And then of a cone, again, 1/3 base area times the height. Well, the base area.
So again, pi r squared times
The height.
height. Remember, that's the perpendicular line here, so
Right.
it's coming from here.
Right, so what relationship exists between the radius, the height, and that S slant height?
Ooh, I know, it's a right triangle.
Ah, right.
Fancy. And that,
Right.
that's when we can use a squared plus b squared equals c squared.
Right, and so in lots of these pyramids, there's lots of Pythagorean theorem that comes out.
So sometimes you'll be given your slant height and you might have to solve for the height.
Right. Okay, and then finally our sphere. Well, that's one you just have to know is 4/3 pi r cubed.
There we go.
All right. I think let's go to the next one. Let's see what we have next. I think we already talked about that. Let's go to the next one. Or do you want to talk about the general prism? Let's talk about the general prism there. So
Okay.
again, how we have base area times the height. Well, as we find that volume, that base area is going to be that cross that we're looking at, not the part that it's sitting on. So that cross part, that's going to be the base.
Usually bases have parallel shapes, so if we think about it on the back, it's a parallel identical shape.
Good call on that. So it would be that area times the height, whatever it would be.
Yeah.
Okay.
And this being the height, I guess. Yeah.
Yep, there's the height. All right, let's try an example.
All right, find the volume. Always easy to break these up into two different shapes. Let's first talk about the cone. We know that the formula for a cone is
1/3
okay, 1/3
pi r squared, base area, pi r squared, times the height.
So let's see, we can try to start off by substituting what we know. 1/3 pi, we know our radius is 3. Now here's what we were talking about, the height. We don't know that. Our height is perpendicular to our base here.
Right.
So let's go over here and use our Pythagorean theorem. This is 3, 8.4, and x. So 3 squared plus x squared equals 8.4 squared.
I love Pythagorean theorem.
So we know x squared equals, let's see.
Oh, yep, there we go. 8. Oh, you can just drag that out of the way.
0.4 squared. So we have 70.56 minus 9. All right.
So x squared is 61.56.
Now, if we were to take the square root of it, we would end up with a plus or minus.
But it's a height, so we only need the positive
All
value.
right, so it's always going to be the positive value. So 61.56. X is approximately equal to
7.84. Let's keep more than 3 significant figures so that our final answer is going to be accurate to 3 significant figures.
How about 0, 2?
Sure. All right.
All right, so back over here, 7.84602.
All right, and now we can
just type this in. We can multiply this by 9
right.
times, I'm going backwards here, pi times 1/3.
I like how you put that in parentheses because the calculator doesn't always know what it's talking about.
Gotta be smart in the calculator.
Exactly. So the volume is 73.9.
And this is centimeters cubed. Okay, now we have to go over here and do the cylinder. So I'm going to erase some of my work so we have just a little more room.
All right.
Okay, so cylinder. Volume is?
Pi r squared h.
Pi r squared h. Always state your formula first, then you do substitution. Instead of r, we put in 3 squared. Height?
5.1.
5.1. This is easy. We can just type it into our calculator. So we have pi
times 9.
Oops, 5.1. And we get about 144. 144? Are we going to round 3 significant figures now?
Actually, when we did the 73.9, we probably should have kept an extra decimal place there. So we put the 2 together. We had to keep that to 3 significant figures.
And we can see the value right here. So we'll just go ahead and add this value to 73.9. 47?
Sure, 7.
7. Okay.
And
we get the total volume.
Is 218 centimeters cubed.
You should probably make sure that this is approximately.
Right.
Okay.
Great. I think we'll stop there and do one more example on a second podcast.